We'll orient it like so. Okay, these are going to be kind of a little bit of a different. So on the very bottom of the part, we'd create a face, create a new sketch on that face, and we're going to just put down 2 points. And we're going to make sure those points are vertical to each other. Oops. Where'd it go? Must put it on top of each other. So I'll go undo, undo, and run the horizontal because I've got it turned. And they need to be symmetrical. And they need to be from the end. They need to be, I believe it's 30. The 30 from the end. Okay. There we go. 30. And they are, how far apart? They are 19. Okay, let's see what this is going to. So let's accept that sketch. We'll go back to the hole. And this is going to be kind of different, okay? It's going to be you'll need a counter bore. And the tapped hole is going to be a M3, very small. And we'll take the 0.5 millimeters. So our counter bore, the depth of our counter bore is this one. We want that to be, we'll make it 20. And the diameter of the counter bore is going to be 4. And the depth of it is going to be, this is the drill depth. Now this one is going to be defined by, so counter bore, blind, that's the tap drill, okay? That's the drill. Before they can run a tap, before they can put the threads in there, they have to drill a hole. And each thread, according to its size, has a particular size drill that is used to drill it. It'll be a little bit smaller than the tapped than the tap size because it has to leave room to cut the threads. So I'll accept that. And we'll rotate it around. So you have this hole goes through 4, and then this one's the tapped hole underneath. And gosh, I would sure hate to have to tap that much. That's a tough hole to make right there, I can tell you. But it can be done. I'm not. What this does is it holds a little piece of material in there that kind of makes it this part slide. There's some little retainers. I've actually seen this design before in a vise. These show, not showing the dimensions, is it? There's it right there. You should have the right next to it. You should have your drawing right here, right next to your. Well, part of this is learning to interpret drawings too. If you're going to be making drawings, you need to be able to interpret them. And, you know, everyone does to some extent here. But, you know, it's something that you keep getting better at. So that basically should finish it. I'm not going to worry about the little radiuses and things on there right now. I'm not going to get too detailed right there. Right here. Okay, don't just plug those in, kind of think about what they're doing. I'm talking to everyone here. Once you put them in your drawing, just the first one, the 2.5, that's your tap drill. I wish they would say that there. I wish they'd say tap drill. And the next one is the diameter of your counter bore, which we made it a 4. And then the depth of that, you could make that 20 as long as it comes out, as long as you make this depth go through this first section, then you're good, okay? It could be a little bit less than 20 and still be okay. But it's 20 to this. Yeah, it's 20 to the bottom of the hole. It's 15 through this piece here. They have to drill through that piece and then come in behind that with some sort of a special tap that would be very fragile. These small taps, those tiny little taps, they break so easy. When you break them off in a hole that you're tapping is just, it's a nightmare in a lot of cases. Because you can have a lot of in your part and you break a tap off into it and it's over. Not yet. Not, I mean, so I've got some other little parts here I need to bring in. Hold on. I'm going to pause the share. Oh, we're not recording yet. Okay, but, huh? Yeah, that'd be a good. So I'm going to pause share and go over here. Let me do some maneuvering. There's a bunch of real small parts. We'll try to get one of them done here. Okay, in your Schoology, there's a folder in there, March 3rd. Okay, this is the rest of the parts that make up the assembly. These are, we'll do this one right here. We'll do in class today, and I'll try to remember to turn my video recorder on so we can record it. Whoops. Okay, this is in your Schoology under March 3rd, small parts dimensions. We're going to do this one today. Yeah, we'll do this as a revolved part. Okay, we'll sketch this profile, and then we'll do all of this revolved at one time. That's the most efficient way to do this part. Yeah, because of the different changes in diameters and undercuts and things like that. You would have to set up planes and do bi-directional. It wouldn't be, the way to do this one is, or you could just stack them up. I've seen people they'd make a cylinder here and they'd make it 13, and then they would make another one on top of it. Then they would make another one on top of that. They would make another one on top of that, and then it would make another one on top of that, and then another one on top of that. You could actually stack cylinders on top of each other and make that part. This is going to be a VS3. I definitely need to go back and edit this and this is going to be the VS-3. And then dash your last name first, and then your period, fifth period. So we'll get started on that. How much depth where? You revolve it. Here, you're about to see it. Okay, we'll do it. Yeah, there's a couple of different approaches. You could stack. The most efficient way is we're about to do it. So I'm going to create a document, and this is going to be VS-3- then your last name, first name, and then 5P for 5 period, 5th period. I've already done this about 3 or 4 times now, so we'll start the part, and I'm going to choose the right plane because I know it runs in that direction. If you choose another direction, I mean, there's nothing wrong with that. It's just you have to do more turning. When you go to put it into the assembly, it takes a little more work to do it that way. If you start off with everything oriented like it fits in your assembly. Okay, so we go new sketch on the right plane. Do normal. And my first, oh yes, thank you. That would be pain in the butt. Workspace units are going to be millimeters. And kilograms. Save that. Now, here's something, if you get tired of doing, like right now, we're going to be doing several parts here that are all going to be metric. So if you go over to your account over here, go to my account, you can change your preference of your units, and you can change that over to millimeters and your grams, millimeters, and then save that. If you know you're going to be making a lot of particular parts, in this case, metric parts, so, or if you're making a bunch of inch parts, so you can change it here, so you don't have to get caught up with that. We'll go back into my drawing. And just to be sure, my units are still, yeah, okay. So I'll go back and edit the sketch. Right click, view normal to sketch. And so I'll just make a line down here at the bottom. And this is going to be a work, we'll make a work line. So our part's going to be like 160 long. So I can make it at 160. That's it's a 16 thread, 16 millimeter diameter thread. But 2, that's the 2 is going to be the lead, the pitch. The lead is, if it's just a single thread like this, the pitch and the lead are the same thing. When you, okay, look. Okay, if you put your center line down, and then when you make your, you can just kind of estimate them at first, okay? And you just sketch that profile. And it's starting with your smallest dimensions, okay? Your smallest ones on here. So if I go to dimension and then click this, and in that line, when I drag down below that line, okay, that, notice how it goes to a diameter. Look at your, and this one's going to be a diameter of 13. This one's going to be a diameter of 19. This one's going to be a diameter of 16. This one's going to be a diameter of 13. This one's going to be a diameter of 9.5. And then this one's going to be a diameter of 13 again. Okay, now we'll do the horizontal lengths. This one will be a distance of 20. This will be a distance of, looking at the drawing here, of 7. Between these lines, this line, and this line is a distance of 101. And then this distance is going to be 9. This distance is going to be 4.5. Yes. And this distance is what's left over. It's going to be 20. And something didn't add up here. (2013) 7 101. I'm going going to delete this one. I want to let me. There it goes. So these are the dimensions on your so now I just wonder how long this is. We'll take that. Something's not adding up. So this 160 here, it may give you problems. If it gives you problems, you'll have to delete it. Yeah. Which measurement? Yeah, mine came out to 161.5. Yeah, there's some rounding that happens. There's some precision that didn't get. Yeah, that's my bad. I'm the one that did that. So I did this first. I did it in Inventor first. And then when I put the dimensions down, I rounded. It has a conflict. But go by the dimensions on the. Don't go by the overall. Go by the dimensions that are the length of each feature. Ignore the 160. Yeah, you can do that on the bottom. I just need to extend mine somewhere. It should be grayed out right now. That's because of that rounding error. Well, let's try. We'll try revolve. Revolve axis. I think it's open right there, isn't it? Yeah, I'm gonna redo the bottom line on it. Yeah, but I don't see where to close it. Right there, extend. Let me go back to my sketch. I got to go back to the sketch. It looks closed. I thought it was closed. This one? Right there? It looks like it is. It looks like my endpoint is, oops. Okay, I'm just going to redo my bottom line. Won't let me. There it is. So it won't take a center line. If I turn that into a center line, then so if I select that and turn it into a center line, it won't. That's why it's open. See, the other program, Inventor, it requires that center line. This one doesn't like it at all. It wants to be closed. Okay. So now that'll do it. Revolve axis is going to be that. So there it is. There's a hole, yeah, through the end. We can go ahead and do that. So if I orient the part, either one of these planes, either the right or the top, you can make a sketch on that. And then do a view normal. And over here, when you do that, if you want to draw that plane, you can go to a section view. And click that plane and it'll cut that out so you can kind of draw on your some of you just looked up and saw that, right? You didn't see me do it. You just saw what happened. So that's 8.2. And it's got to be 10 from the bottom. How did I slice that view like that? Over here, there's a turn section view on and off. Okay, if you go translucent, you can see it and work with it. Or you can do the section view here and then draw on that. And over on your, you find it? Looks like you did. Then extrude it both ways, all. Cut as a remove, symmetric. That's the part. To do what? So that's this part. I'm gonna go ahead and stop the recording on that. Change the blind to symmetrical. Cut. You want to cut. Hmm? So I'm gonna stop right there. I'm gonna go ahead. Does anyone have any questions on this part or on one of the other parts before I end the meeting?